Welcome to The Explainer. Today, we are pulling back the curtain on a surprisingly simple technique that can make the AI applications you use and maybe even build dramatically faster and, get this, cheaper. It's called prompt caching, and honestly, it's a total game changer. Okay, let's just get right into it, because we've all felt this. You're using an AI tool, you ask it a question, and there's that pause, that lag. It feels sluggish. And if you're the one paying the bills for that AI, you know every single one of those slow responses is literally costing you money. But what if I told you that you could take that exact same AI model without changing a single thing about it and make it up to 50% faster? And what if you could cut the costs by as much as 70%? I know, it sounds a little too good to be true, but this is the real-world power of what we're talking about today. So, what's the real problem here? Well, a lot of the high cost and the slowness of AI comes down to one thing. It's doing a ton of repetitive work. The models are often rereading and reprocessing the same exact instructions over and over again. It's a huge waste of time and, of course, your money. But the fix? Well, it's deceptively simple. And that solution is a really powerful technique called prompt caching. The whole idea is to look at your prompt and figure out which parts don't change. You know, the system instructions, the background info. You have the AI process that part once, and then you just store it. That way, the next time, the AI only has to think about the new stuff.
This quote right here, this is everything. It pretty much boils down the entire philosophy behind caching into one simple, powerful rule. It's the guiding principle. If the model has already done the heavy lifting once, for goodness sakes, don't make it do it all over again.
To really get how this works, let's step away from the tech for just a minute. I want you to imagine we're in a busy coffee shop, and your large language model? It's our very efficient but very literal barista.
So think of it like this. The LLM is the barista. The complicated, unchanging base recipe. You know, how to brew the espresso, how to steam the milk just right. That's exactly like the AI's static system instructions. And the part that changes every time, the customer's name on the cup, that's your specific question, your user query.
Now, to get just a little technical for a second, under the hood, the AI has a special kind of memory for this base recipe. It's called the key value cache, or just KV cache. That's the spot where the model stores its understanding of that static part of the prompt. Okay, so the very first order of the day comes in. Our barista gets the whole shebang, the full recipe, and the customer's name. They've got to do all the work from the ground up. In the tech world, we call this a cache miss. But here's the clever bit. After making that perfect drink, our barista saves that base coffee for later. So what happens for the next order? The next person walks up, gives their name, and does the barista start all over again? No way! They just grab that pre-made base, slap the new name on it, and serve it up. That's a cache hit, and it is so much faster and way more efficient. And this is where it gets really exciting, especially for your wallet. The AI providers, they see this efficiency. So when you get a cache hit, they often give you a massive discount. We're talking up to 90% on the cost of those parts of the prompt that were already processed. So this sounds great, right? But how do you actually make it happen? Well, if you're a developer, you've generally got two main ways to go about it, and they each have their pros and cons. So on one side, you've got implicit caching. This is the easy button. It's totally automatic. The AI provider handles everything for you. Zero effort, which is great for most apps. On the other side, there's explicit caching. This gives you, the developer, all the control. It's more work to set up, but it's an absolute lifesaver for complex stuff like when you're reusing huge documents in a RAG system. And this brings us to a really crucial point. You are not just a passenger here. The way you actually structure your prompts has a direct and frankly massive impact on performance. You can literally design your prompts to make your AI absolutely fly. It really just comes down to three simple rules. First, always put your static stuff, your system instructions, right at the very beginning of the prompt. Second, if you have big documents you're using again and again, explicitly cache them so they're always ready to go. And third, keep an eye on your cache hit rate. That tells you if your design is actually working. But I have to give you a critical warning here. These caching systems are extremely sensitive. I mean, they are picky. They need an exact match on that first part of the prompt. That means even one extra space or a tiny change in formatting between requests can completely break the cache. And then all those speed and cost savings, gone. And just so you know, this isn't some obscure feature for nerds. This is a core part of how the heavy hitters operate.
We're talking OpenAI, Google, Amazon. They all have powerful caching systems built right into their best models because they know you can't get performance at scale without it.
So, the big takeaway here is that prompt caching isn't just some nice little trick. It's fundamental. It's one of those key things that separates a slow, expensive AI prototype from a fast, scalable, and cost-effective application that's truly ready for the real world.
And that kind of leaves us with a final thought to chew on. We've just uncovered one of the invisible engines that makes modern AI actually work. It really makes you wonder, doesn't it? What other hidden optimizations, what other clever tricks are quietly shaping the speed and feel of our entire digital world?